Problem 5A4. We have a fire hydrant, same cross section everywhere. Let's call the velocity of the water here V2 and the velocity of the water here V1. And the magnitudes are the same and they are 25 meters per second. I have L kilograms of water per second flowing through there, and the velocity V2 and V1 is 25 meters per second. And this number is given. Now, the velocity is changing from this to this. The speed is not changing, but the velocity is changing. So if this is V1 and this is V2, then the change in velocity, this one, is V2 minus V1, and let's call that for simplicity delta V. If there is a change in velocity, there must be a force on the system. Well, remember the P dt, or let's write down delta for now, delta P delta T, which is a change of momentum per unit time, that was an external force. Well, what is delta P? In the extreme case, of course, when delta goes to 0, it becomes dP. Delta P equals m delta V. That's this delta V. And this is delta T. But what is m divided by delta T? That's this L. That's the number of kilograms per second. And what is the magnitude of delta V? The magnitude of delta V equals 25 times the square root of 2. So what does it mean? It means that the wall must push on the water in this direction, in the same direction as delta P, and you can calculate the force. Now, since action equals minus reaction, the water will push back on the wall in exactly the opposite direction, but the same magnitude. And so I think you have enough ammunition now to do this problem.